All right, I'm going to go over circles. So a circle is just a figure that is the same distance from one single point. And you guys have seen these before 1,000 times. So it looks like this. The distance is what we call a radius, right? So you guys all know this. So there's an equation that we're going to have in Algebra 2 that tells us what the equation of the circle is, the information, so we can find any point on here. Oops. So what this tells me is x minus h squared plus y minus k squared equals r squared, where r is your radius, h and k are your center. And this will tell me the location of any point on this circle. So h stays the same as we've seen it before, it's x minus, but k is kind of different because now it's y minus k. Doesn't matter. Okay, so if I'm looking at a circle and it tells me this, looking at an equation and it tells me this, and it wants me to graph it, first I'm going to find the center. The center is going to be 3, negative 2. And my radius is going to equal the square root of 9, which is 3. So on a graph, I'm going to start at negative 2, 3. And from this, I'm going to go 3 units in every single direction. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's kind of an ugly circle, but that's what we're looking at. That's what we're trying to do. Okay. So, how can I trick you with circles? Well, it's kind of hard, but I'll do my best. So what you'll see sometimes is you'll see something like this. And you're thinking, oh crap, now it's divided. Well, notice if I multiply this whole entire equation by 16, it cancels this and this. So really what happens is I get x plus 2 squared plus y minus 3 squared equals 16. So my center is at negative 2, 3. And my radius is the square root of 16, or 4. So that's the best I can do to trick you on these guys. Nothing else I can really do. I will give you some fancy ones that tell you something like this. So what's fancy about this? Well, your center is at negative 3, 6, but your radius equals the square root of 7. Big whoop, it's still a number. Super simple. Okay, so what do we need on top of that? There's a thing called a tangent line. What a tangent line is it's a line that comes by and touches the circle at only one point. The tangent line will always make a perpendicular line with a radius. What happens is as I move the tangent line, it just changes where the radius comes from. But it's always going to be that radius, from the center to the tangent line. So if I'm trying to do the equation of this guy right here, and I know that the equation of the circle is this, and it tells me the tangent line goes through the point 3, 4. I'm going to find first the slope of this line right here. So the slope of that line, I'm going to use my center to the new point that it gave me, which it's giving me this point right here is 3, 4. So the slope of this is y1 minus y2, which is negative 3 minus 4 over x1 minus x2, negative 2 minus 3, negative 7 over negative 5, or 7 over 5. I told you this was perpendicular, so the slope of this line is perpendicular, which means it flips and changes sign. This is the slope of this line up here. So the slope of this line is this, and it goes through this point. You guys should remember the equation for point slope form. You probably don't, but here it is right here. So I'm going to use my slope of negative 5 over 7, my point of 3, 4. And in order to find the slope of the line, I got to get it into slope-intercept form. So I'm going to distribute here. And then I just want to bring the 4 over. When I add 4, I need it to have a denominator of 7, so 4 over 1 equals 28 over 7, plus 15, 43 over 7. That's it for the tangent line. Pretty simple. Now, how can I trick you even more? Well, if I give you this, what's different from this? I have an inequality. So you guys know this. These inequalities mean that it's a dashed line. So what am I going to do if I'm trying to graph it? I'm going to find my center, which is at -2, -3. I'm going to go the square root of 14. Great. Good job, Lothamer. Let's make it 16. Square root of 16, which is 4 units away. It goes 4 units in each direction from our center. Now remember, I just told you it needs to be a dashed line, right? So dashed line. Now you guys have learned how to test if the point needs to be if you need to shade towards 0, 0 or away from 0, 0. You can use that method, but there's an easier way. The easier way is if it's greater than or equal to, you're shading on the outside. If it's less than or equal to, you're shading on the inside. And that's it. There's going to be a little bit more tricky stuff on there, not really, and we're going to practice it in class.